Okay, welcome to note set M05, where we'll continue our discussion of MATLAB. And here we're going to talk about scripts and functions. So you may be familiar with the term function from math, and this is kind of similar, but this is more, you should think of function more like a program. And a script is essentially a program too, but it's a little more limited in what it can do. So we'll try to draw the distinctions between those and let you see what they are. So scripts and functions are the things that you can use to write programs in MATLAB. As we've already seen, MATLAB is a command line environment, as well as we'll see in this set of notes, a programming environment. So we've been just entering a series of commands that we enter the commands one at a time at the MATLAB command line, and it does them. And it works like a glorified calculator. Each command that we run can do a computation and then store that result in a variable, and then we can recall that variable in the workspace. But imagine if we had a fairly complicated computation and we needed to do multiple commands to do that. Well, we could just enter them one after another at the command line and do our computation. But it would be nice, especially if there were lots of things that we had to do, and maybe, there it is. And maybe we wanted to do them over and over and over for different scenarios. We could put all these commands, if we could put all these commands into a file and then feed that file into MATLAB, and MATLAB would just use these commands over, just one after another from the file. That would be convenient. Well, that's kind of what a script file does. It's really nothing more than taking a bunch of commands that you would otherwise enter at the command line, and putting them into a file, basically a text file, although it would be stored as a .m file. But it's really just no different than a text file, other than the .m extension to tell MATLAB that it's something that it can work with. And then once you quote-unquote run that file, as we'll see how to do in just a little bit, MATLAB just says, okay, I'll run whatever's on the first line as a command, I'll run the second line as a command, and so on and so on. How do we create these text files? But really they're called M files. MATLAB has a built-in editor. But we could use any text editor to create these as long as we can rename it .m. But there are a lot of advantages to using MATLAB's built-in editor, but sometimes you find yourself with an M file that you need to change, and you're on some computer that doesn't necessarily have MATLAB, and you can just edit it in a text, any kind of text editor. We've already seen that MATLAB has a bunch of commands or functions already built into it. We've seen things like rank and reduced row echelon form, RREF. Those are functions that MATLAB provides for you to use, but we could write our own, and then we would call these just like we would call any pre-built MATLAB functions, and that's really the power of MATLAB. So as I've said, there's two different kinds of program files in MATLAB. The first is called scripts, and they're useful to a certain degree, but really functions are the more powerful thing. But scripts sometimes are handy to just write something quick. Their key limitation is that they do not accept any input arguments, nor do they return any output arguments. And we'll talk a little bit more about what we mean by input arguments and output arguments. And they operate on the data in the workspace, and any of their results are just spilled right back into the workspace. Now that fact can be helpful but also harmful sometimes, and we'll touch on that a little bit later. Functions, on the other hand, The only way to get something that's in your workspace inside the function is to provide it to the function as an input argument. So remember when we called the command RREF, reduced row echelon form, we had to put the name of the matrix variable that we wanted it to work on inside parentheses. So, and we had to give a name for the result. So we would say R is equal to RREF parenthesis A end parenthesis. So we'll see that structure and how we can build that structure into our own function. So in that case, the matrix A that we're putting in is called the input argument, and the matrix R that we're getting out is called the return, or not the return, it's called the output argument that is return. Now the cool thing, and this may sound like it's a limitation, but it's actually very, very helpful. Everything that you used inside as, say, temporary variables inside the function, they don't get spilled out into your workspace. So if you're doing a lot of work inside this function and there's a lot of trash left over, and there's one final matrix that you want, you return that final matrix as the output argument. So that's the only thing that makes it out of the function. Everything else, once the function terminates, is annihilated and is not left to clutter up your workspace, nor will it overwrite anything that you have named that. So that's one of the dangers of using a script. Suppose you named something in your that's in your workspace is called temp, T-E-M-P, and you just call some script. You don't look carefully to see what that script does. At some point in that script, it might redefine the variable temp, T-E-M-P, and it will overwrite whatever you had as your temp. So when that script is done writing or done running, you think the temp variable holds what it used to hold, but it doesn't. Now, if we were doing that with a function, and inside the function assigns something to some variable called temp, first of all, your temp is not inside that function unless you passed it in, and even then it's just a locally generated copy of that temp that you've passed in. The function will do a bunch of calculations. It may even assign something to a variable called temp, and unless it is outputting that as an output argument, that temp will never get back to the workspace, and your original temp variable will not have been overwritten. And so that's kind of the beauty of that, and that's what makes functions very, very powerful. So let's just talk a little bit about scripts. Like I said, they are used sometimes, but they're not the most widely used, and it's not where the power really lies. Basically, it's just a way of putting a bunch of commands, one after another, into an M file, which is just a text file named .m, and then when you give MATLAB the name of that function, or the name of that script, it just goes and executes those commands one after another. So they operate on existing data in the workspace. So whatever is already named in your workspace, that's what your script has to operate on. They can create new data on which to operate, but it will be left behind when the script is done. It'll be there to clutter up your workspace and could potentially have overwritten something that you already had named something. So scripts don't return anything as an output argument, so there's no way to do that. But all the variables that were created in there, unless they've been rewritten or cleared inside the script, they will be in the workspace after the script is run. And like I said, that can be useful, but more often than not, it causes problems. Now, inside a script, we can also produce graphical output. So we can put functions like plot and so forth in there. Now, that's not unique to scripts. We can also do that inside a function, as we'll see. So how do we create a script? If we wanted to create something called magicrank.m. I always kind of read that as magic crank. Then we just need to create an M file using the MATLAB editor with these commands in it. So let's see how we would go about doing that. And for the life of me, I can't remember how to get over to my MATLAB. Let me see if I can figure that out. I should have looked into this. Aha, there we go. I think that was the trick there. Yeah, okay. So I got it. Don't want Skype. I'm in my thing. Okay, there's my MATLAB. And I'm really hoping that the video is still recording. Well, let me let me go back to my yeah. So let me go here. I'm going to grab those lines here and show you how to actually make a script. So let me just copy those. And now let's see if I can scroll my way over there. Okay, so now I'm in MATLAB, and I'm going to go up to Home. I'm going to click on New Script, and I'm going to put those commands that I just copied. So there they are. We'll talk about this % line. That's a comment line. You can see that it turns green. But that's we'll talk about what comments are used for later. So I would type those commands in instead of just copying them from someplace, but rather than typing them in, I thought I would just put them in quickly. And now I'm going to go to Save, and it will save it in my current directory that MATLAB's pointing at, and I'm just going to call this, as we called it, Magic Crank. Magic Rank is what it's supposed to be. And I've misspelled it there. So there's magicrank.m. I'm going to hit save. And so now you can see up here it tells you that the name that it's been saved as. And you can really name it as anything that you want. And now I could run this by just going up and clicking on Run, or I could go over to my command line, and now I'm just going to type magic rank, and it will run those commands. And so there it ran the commands and made the plot that those commands would normally make. But notice that it left behind the variables n and r that it created. So if I come over here now, I can look at the editor. So it created an R, and then it used an N for a loop. We'll talk more about loops we'll talk more about loops later. But this is a for loop. You've probably learned about those in previous programming classes, but we'll talk about those more later. But when it's all done, there are two variables, R and N, that have been created, and those are left. They're sitting there in our workspace to clutter it up. Now here's the problem. Let's clear this. So now they're gone. Now suppose I said R is equal to 5. There's my favorite variable value. R is equal to 5. Now suppose I need that for something later. Suppose it's more important than just the integer 5. Now I run magic rank, and well, R is still there, but look, R is now a 1 by 32 array, not just a scalar like it was just a second ago. So that's the danger of using a script. Plus there's no way to pass any information into magic rank. I have to always run it exactly as it is. So we go over here, and suppose I wanted to do have this be a program that would do this for a number other than 32 that I get to choose at the time of running. Can't do it this way. Not easily anyway. So there's no easy way to have it be kind of a customizable function. And that's what we'll talk about later. All right, so let me see if I can get back to my, yes, there's my presentation. Hopefully all that got recorded. And yeah, so you already saw how I did this. I just typed magic rank at the command line and it ran. So don't worry about what that what that script does. It's not terribly important, but it's creating this nth order magic matrix and then finding the rank of it and then making a histogram of it. So this command bar makes a bar plot, not a histogram plot, but a bar plot. Okay. And as we've already seen, after execution of the file, the variables n and r remain in the workspace, and I showed you the danger of having that be the case. Okay, so let's move on here. And now we're going to talk about functions, which are really the much more powerful and useful programming features of MATLAB. So MATLAB function is a MATLAB program that performs a sequence of operations specified in the text file. Sounds an awful lot like a script file, but the main difference is that a function will accept one or more MATLAB variables as inputs. So I can predefine these variables, as we'll see. I can, put in any variable that I've already created, but I can also put directly into the function call actual numerical values without calling them something. And then it returns, well, it says here one or more. It could be 0. There may not be any output that's returned, but typically they return something because we're often, it's rare that we're not interested in getting anything back from the function. But notice that they may also generate plots, so maybe all we want is the plot. We don't necessarily want an output, but it's most of the time we want a function to return something to us assigned to some variable name. So we'll see in a minute that there is a function name that is specified inside the file, the M file, and we should have the function name and the file name be the same. If you don't make it the same, things will still kind of work, but you can run into some funky scenarios. So functions operate on variables within their own workspace. What does that mean, within their own workspace? So as soon as I run a function, my existing workspace is kind of suspended, and I go into kind of a temporary workspace where the only variables that are in it when I first go in there are anything that gets passed in as a function or as an input variable. And so then I'm working in this temporary workspace. I can start to use any of the passed in variables, and anything that I create within that function is usable until the function ends, and if it's not passed back out as an output variable, it'll go away. So you have to pass in as a variable anything you want the function to have access to. And that may sound like it's a limitation, but actually it's good. That way you can have this operate on anything that you want to give it, and it will operate on it. And as I already said, all variables created inside the function are deleted when the function completes its operation. So if you want a result available after the function, you have to output it as an output variable. And when you do that, it becomes available in not the temporary workspace that we talked about here. It becomes available in your original workspace from which you called the function. So how do we write a MATLAB function? Well, the first line of a function must contain the function definition, which has a general structure that looks like this. So we put some function name here. We give a list of the variables that we want to pass in, and we can call them anything that we want. These are the names that we'll use in our program. And then when we call it, we can substitute in the real variable names that we want to pass in. And we'll see in just a little bit how that works. And then out1, out2, all the way to outn, those are the output variables. And we can call those anything that we want. And when the function is done operating, whatever we have here, that we should have created those so that they can get sent out of the function. The most important thing that we need is at the start of it, we need a function command. That's telling MATLAB this is a function and not a script. So if there's only a single output variable, we don't need the square brackets at the output. We can just say whatever that output variable name is. And we don't necessarily have to have an output variable. We could just specify a function here without putting anything there as an output variable. In this case, all the computations that are done inside the function will disappear. So presumably this function, to be useful, created some sort of graphics. Otherwise, there would be no point in doing that function. So after this first line, where you use the function command to tell MATLAB that you're defining a function, that's the function definition line, then you just put one command per line, just like you're working in the MATLAB command line environment. And those commands will be operated on one after another. So, so once we've got our function and we've put in our input variables, so as we saw over here, we've got a function named a function name, and we're saying that we're putting in variables called in1, in2, all the way out to in_m. These are literally the variable names that we'll use. So if we want to do a computation with in1, suppose we want to square all the elements, each element in that, we would have a line in our function that would just say y is equal to in_1 dot hat 2. That will square all those. And so now inside our function, there's a variable called y. That's the square of the elements in whatever I put in the location of in1 when I call my function. Same thing with output variables. So if I had something called out1 listed here in my creation, so maybe I just have a single one of them and I have it defined like that. Now at some point in my function operation, I do this command. It will take the cosine of all those y values that we just created. And again, I don't have to call these in1 and out1. I can call them anything that I want. Now let's talk a little bit about comments. I can put comments in my program, and I can do this in a script file. I can do it in a function file, either one. The percent symbol tells us that what comes after it is all comment. And so comments can come after commands. So you can see that down here. I've got a command here, and then I put a semicolon if I don't want the result to be spewed out. And generally that's a good thing to do in an M file, is that you don't want all these results spewing out onto your screen. So you put a semicolon there to suppress it, and then you put a % sign and write whatever you want. And in the MATLAB editor, comments will show up in green text. So it's just a helpful way to keep track of them. But comments can also be a complete line. So here you see I've got my function defined. So this is some function that I wrote a long time ago called frames, and I need a single input variable called theta. See, I don't need to call it in one, and I've got 1, 2, 3, 4 potential output variables, which I call X hat, Y hat, A, and B. I don't need to call them out 1, out 2, out 3. They can be called whatever I want. So then immediately afterwards, you see I have a bunch of lines which are all just comments. And this is a good time for me to talk about proper style. So this is what is expected of you when you write an M file, whether it's a script or a function. In this course, and I will say in subsequent courses, you will be expected to follow this proper style. So the first thing we want to do is just put a little, let me clear some of this stuff off here so we don't have all this garbage here. Come on, there we go. So the first thing we do is we just give a little description of what the function is going to do. So this isn't going to make much sense to you because this is something that I made a long time ago when I was studying this thing called frames, which is kind of a generalization of something in linear algebra, which we won't really talk about in this class. But I wrote this little function to play around with this, and so there's a few descriptive things that tell somebody, at least somebody who knows what frames are about, what this does. And then, so that's the description of the function, and you can be as brief or verbose as you want for that. You should write enough so that somebody who kind of knows, the theoretical ideas that your function is based upon can understand what it is that it's going to do. The next thing you should do is put a usage line, and that shows the user how to call this function. And here, I'm guessing I wrote this before I started to include 2 additional output variables. So technically I've made an error here. I should have comma A and comma B here. So bad style on my part. Then the next thing we're going to do is have input list. And since there's only one input here, we just have a single thing. You just explain what it is that variable theta is. And so I'm telling you it's the angle of the unit second vector. So we're going to create a bunch of vectors in this function, and this is just telling us what it's going to do. So I'm telling you it's the angle, and I'll often say whether I'm expecting an input to be a scalar or a vector. We'll maybe see some examples of that as we go through this further. But it's also important to tell somebody about the units that you're expecting so that they know what to put this in. What units to put it in. Then we've got a list of outputs, and you can again see that I must have originally written this without A and B, so maybe we can just cross that off. All right, so now I've got my list of outputs, and I'm telling you that there's 2 outputs that will come out, and I tell you that X hat is possible X locations of the third vector, and Y hat is possible Y locations of the third vector. And again, sometimes it's helpful to tell the user whether these things are going to be scalars or vectors, and if there's units involved, tell them what the units are. And then if there's going to be any plot made, you might want to tell the user what those plots are going to be and what colors correspond to what. And then this just shows the first 2 lines, but there was a bunch of lines after that I didn't include here. So let's back up here. I'm going to go back over to this example here. I'm going to scroll back over to my MATLAB, and I'm going to make a function here. So let me get rid of that figure 1. Let me go up here and get rid of magic crank. I'm going to create a function. So I'm going to go up to home. I'm going to go to new. I'm going to go to function, and look, it comes up with a prototype structure for you already. And you should fill in all of this stuff. If I see you turning in stuff that just leaves all of this generic stuff here, I'm going to be a little bit bothered by this. And any other professor who's using these, I would think would also be bothered by that. So let's do what we just did in those. So we're going to have one input, and I'm not going to call it in one. I'm going to call it like X. And then I'm going to call this, I don't know, something descriptive like test function. I can call it anything I want. Let me use an underscore there. And my output arguments, I'm just going to have one of them. So I don't really need the square brackets, and we'll call that Y. So I could put in here all the usage and all that stuff. I'm going to skip that for now just to make things go quicker here. But I showed you how to put, what you should put in there, and I've now told you that you should put that in there. So remember, we said we were going to take and create a variable. Let's say that we were going to square all of the x values. So I'm going to say, let's call this x squared is equal to x dot squared, and put a semicolon there. I could put a comment after that if I wanted to. And now I'm going to say y is equal to cosine of x squared. And we'll leave that like that. And so whatever I put in here, and it doesn't matter what I call it, whatever I put in there will end up showing up here as an x. So even if when I call this, I say test function parentheses b, inside this function it will reassign what I had as b to x, and then it will operate as x. It'll square it and create this x squared variable, which it'll then take the cosine of that. It will assign it to y, and end of the function, so it outputs it as y. So let me just save this now. So if I save it, you'll notice that it automatically captures what I put in as the function name and puts that as the file name. So it'll automatically do that for me. I save it. Okay, so now I have this function called test function. Now I can go over to my command line, and suppose I create b is equal to 1 to 10. So there's my b variable. And just for fun, let me create a y. Let me say an x squared is equal to 5. So I've, made an error there. So I've got an x squared already. I'm going to show you the distinction between a function and a script. So I've got the x squared in my workspace. And so now I'm going to run this. I'm going to say y is equal to, I called this test function. And remember, when I wrote it, I said test function of x. Ha! And look at that. It's already created help for my function. And so it's giving me a hint on how to fill that in. If I had put in all that proper style stuff with the usage and everything, when I click on more help here, it would actually show me all that. So when you put all that stuff there that I said is proper style, you're actually creating your own help for your function. That's why it's crucial to do that. And so when I wrote this, the variable name that I used for my input variable was called x, but I can use anything I want. I've got b defined, so let me put b in there. So now I put that in. I'm going to put a semicolon there so it doesn't spew out all the variables, and I'm going to run it. And so now what's in y? Well, it will be the values that would come from squaring 1 through 10, and then putting those numbers into cosine. So let's just test this to see if it works. So the second element in b is 2. So I'm going to take 2 squared. I'm going to take cosine of 2 squared, and so that gives me the value that I actually got here. Now, here's the other cool thing. notice that inside my function, I created something x squared. Well, once that function finished, well, let me say it this way. When that function was running, it did not have access to the x square variable that I had created in my workspace. It creates that in its temporary workspace. And when the function is finished, it annihilates that temporary workspace and does not interfere with my x squared. So let's go back and look. My x squared that I had defined already is still there. If I had written this as a script, first of all, I'd have no way to pass in the variable of any particular name. It would have to operate on something called x already in the function, or already in the workspace. Then it would have overwritten my x squared. So there are some limitations to using scripts, and functions allow you to overcome those. So like I said, functions are the workhorse here. So let's see if we can get back here. Here's our where we were. We did that already. We talked about that already. And we've already seen how to run an M file. I just created something called test function. And when I call it, I do not have to use here nor here the same names of the variables that were used to define the function. I can put in anything I want. If you remember, when I wrote my test function, I put in an x here, but when I called it, I put in b there. Now, I did, when I wrote it, put in y here, and when I called it, I put in y there. I can do that. I don't have to. I could have put z there, and it would have reassigned the result of the internal y to my preference of z when it called the function. So once you have something saved as an M file with a name, all you got to do is put that at the command line. So for functions, you call them like this, using the appropriate input and output structure. For a script, you just put just whatever you called the script at the command line, and it will run. Doesn't take in and put out any variables. So how do you test an M file? How do we make sure that it does what we think it does? Well, once you've written it, before you tell somebody, here's my written function, you better test it to make sure that it's really doing what it is saying it's going to do. So you saw when I wrote that little test function M file, I ran it and then I kind of tested it to make sure. I said, well, it says that this is the output, and then I tested it to check just one of its variables or values. How to test an M file depends on what the M file is trying to do. So it kind of boils down to how clever and thoughtful are you to kind of think through all the possible errors that could occur. Guarantee you there will be functions that you write that you don't think through all the possibilities. But if you start thinking carefully while you're writing it, you should be able to kind of figure out what are the important conditions that you'll need to test. Now, the first time you run your M file, there's a good chance that you wrote some error, some syntax error right into it. Maybe that was, some mistake that you inadvertently wrote, and that will cause MATLAB to just stop running and it'll give you an error message. So let's see if we can go simulate that scenario with our setup here. Okay, so let's say that we do something different here. Let's edit our file here, and let's say that we call this x, z. Now I'm going to put in two different variables, and let's make this something different. Let's call this x2, and instead of just squaring x, we're going to take x times z. Now that requires that the dimensions of x and z have some appropriate, or are appropriately related to each other, so that multiplication is valid. And so let's change this to x2. Now you see that little asterisk right there next to that? That's telling us that it's not saved. So I need to save it, and now I'm good to go. So now I can recall this. It's expecting 2 input variables. So let's screw this up so that it doesn't work. Now this will be a syntax error based upon improper calling, but there could be a syntax error even when you properly do it. So let's call this improperly, and we'll create x and z. In fact, I'll show you how you can call a function without even creating a named variable. So we're going to go back up here. I'm just going to use my up arrow to kind of go back through. So I've got my b, which is a 1 through 10, and I'm going to go comma, and then I'm also going to go 1, 2, 3. So now when I do this, this is going to go in as the x, and this is going to go in as the z. And you can see that those are not, it's not possible to multiply this b times this 3-element vector. So I will get an error when I run this. So I run it, and sure enough, there's a little ding. Maybe you heard that. I don't know if the microphone captured that or not. But there was a little ding, and it will also give you something back. It says there was an error using this command. It says inner matrix dimensions must agree. It's telling you what the problem is, and this is nice. It's telling you where in which function and on which line is it occurring, and it's actually showing you the line here. So now we can kind of come back over here and say, okay, the error occurred right here on line 3, so I better figure out what the problem is. And maybe it's just a problem in how you called it, or maybe you just totally programmed it wrong and it will never work, or it won't work when you're putting in the correct form of variables. And so now you can fix it and figure out how it's supposed to work. All right, let me see if we can scooch on over here. Okay, so you saw how we get an error in the command window. A lot of times people will call scripts or functions from the editor. There's I think I pointed out the run button. If you're not expecting your function to take in any input variables, or if it's a script, you can run it from there. And if you don't hear that ding, and you miss that, you might not know that it actually had an error. And so a lot of times people will be running these programs totally unaware that there are problems with them. Sometimes there's not an error, but there's just a warning. There's no ding. It doesn't stop the program. It actually runs to completion, but there was some sort of warning that it was telling you, hey, excuse me, something doesn't quite seem right here. You might want to check that. If you don't go and check at the command line, you won't see that. So how to, testing an M file requires a certain amount of, finesse and cleverness to figure out how do you go about hitting all the important cases. So I can't really teach you that. I can only call it to your attention and ask that you think carefully about how all this works. Now, that leads us to, once you've rid your M file of syntax errors, you need to check to see if your program is really doing what you think it's supposed to do. So this is what I was talking about, where the cleverness comes in. You have to devise appropriate tests. Figure out what are the test cases that are important to check to make sure that everything's working properly. I can't teach you, here's how you always do that. So this is where what you're learning is transitioning from, here's a series of foolproof steps that you just have to know, do these things and you'll get the right answer. It's not like that. This is where you have to start thinking cleverly. This is why companies will pay you large amounts of money to be an engineer. If it's just a matter of regurgitate these steps, they could find someone who doesn't have an engineering degree and tell them, do these steps. And they'd be able to pay them less to do that. Engineering companies want you to be clever so that they can have you do things that are beyond just regurgitating a canned series of steps. If you are clever like that and you can show that you can do that, then you are better off or better able to maintain your employment with that company. Okay. Now, how do we test all this? Well, there's some clever things built into MATLAB that allows us to do that, or helps us do that. And one of those things is called breakpoints. And I'm only going to hit the basics of using breakpoints. But once you know the basics, it's pretty easy to move on into the more advanced ideas. So setting a breakpoint allows you to stop operation at a specific point to test how it's operating at that point. So here's how we do it. We open in the MATLAB editor the M file that you want to debug. So this is called the debugging mode of MATLAB. And we'll go through all this over in the MATLAB environment. You'll see some line numbers on the left of your function that you've opened. Executable lines will have a dash next to the number. If the line is not executable, that would mean it's a comment line. There won't be a dash next to the line. So anywhere there's a dash, you can click on that dash and it sets what's called a breakpoint there. You'll see a big red dot. Execution will stop prior to that marked line. So when you run the M file, it'll run right up to that point and then stop right there, not execute that line, and it will give you back control and you'll be in the function's temporary workspace so you can check to see what's happening. So these things are very useful for function files, a little less useful for script files. In fact, I'm not even sure you can set a breakpoint in a script file. I think you can, but I'm not absolutely certain. So now you run the function. Execution will stop at that point. If you go over to your command window, you'll see at the command line, instead of having just the two arrowheads, you'll see K preceding the two arrowheads. That K stands for keyboard. That tells you that you now have keyboard control at that point in your function. And you can test anything that you want. You can do any computations that you want at that point. You can check sizes. You can do multiplications of things to see how things work. You can check values. So the workspace that you're in is the temporary workspace of the function at the point where you stopped execution. And that's pretty cool. So you can check your results, see if they're correct. You can check matrix sizes to see, are they as you expect? You can check values of variables to see if they are what you expect. Whatever you want. And again, here's where the cleverness comes. How you go about debugging, it's an art form. And so you kind of have to think clearly and cleverly to figure out how to do all this stuff. Once you are at a breakpoint, and we'll see this in just a little bit, I'll take you through this. Once you're at a breakpoint, so here's the red dot that's setting a breakpoint at this point. I've now run this program, and it's stopped at this line where there's a breakpoint. And there will be a little green arrow showing that we are stopped at that point. So now you go, we are in the editor here. We've got our function suspended at this line. We know that because there's a breakpoint set and we can see that there's a green arrow pointing there. And I can now single step through these lines. So if I come up here and I hit this button, step, it will single step through this. And you can see there's a few other things here like step in, step out, run to cursor. And even a continue. And you can read about those and learn how to use them. Continue just basically starts the program back up. I'm not going to go over step in and step out at this point, and I'm not going to talk about run to cursor, but basically you can put your cursor at a point in the function that's now suspended, hit that, and it will run up to the point where your cursor is. So it's kind of like setting a temporary breakpoint without really setting a breakpoint. So you can use the step button on the editor toolbar. Each time you click this step button, it'll execute the line where the green arrow was pointing, and it will move the green arrow to the next executable line and suspend operation at that point. And you can continue doing this, stepping your way through the program, checking variables as you go along to see how things are working. If at some point you think things are all fine, you can click on continue and the program will resume its normal operation and presumably will continue operation to the end if everything is okay. If it hits a syntax error, it'll stop, but if it doesn't, it'll go all the way to the end. Now you can set multiple breakpoints. We only showed setting one. So if you set one breakpoint up at the top, kind of single step through a few lines and then think, okay, I think I'm good, hit continue, it'll go to the next set breakpoint and it'll stop there. So it's a very nice way to set up a bunch of different places. Now, if you're in the middle of doing all this and you didn't hit continue because you think, well, this function's really screwed up, I need to fix it. You can get out of the debugging mode by hitting this quit debugging button in the editor, and that will get you out of this. So like I said, there's a bunch of more advanced features, but these are the basics that will get you going. And to be honest, I rarely, if ever, use the more advanced features. If you want to remove a breakpoint, after you've quit debugging, the breakpoints will still be there. If you think you're all good to go, just remove all the breakpoints. There are some constraints as to editing within debugging. So if you want to edit, you got to get out of debugging by hitting quit debugging. If you save a file with breakpoints set, I think it may undo the breakpoints. I honestly can't remember, but just keep your eye on what's happening, and you'll kind of figure it out as you go along. So that's the end of the notes. I want to go over to here and show you how to do the debugging to some extent. Let's just put in a bunch of additional things up here that are not terribly meaningful. Let's call xx is equal to x plus 4. I'm just trying to create a bunch of lines here. And notice I can leave blank lines. Let's call yy is equal to square root of absolute value of x. I'm just creating some things here that I can then see what happens. So suppose I want to, I don't know why I'm not getting a line there. Because I have a syntax error. That's why. There we go. And now let me save it. Now I have a line there. So I didn't know that. I just learned something new. When you have a syntax error, it won't show you the dash to show that it's an executable line. So that's kind of cool. So now I'm going to set a breakpoint. So there are some fancier things that you can do with breakpoints. If you go up to this button, and it'll pull down things with, you can clear all of your breakpoints. You can set or clear a breakpoint on the current line. You can enable or disable. You can set various conditions. You can do various error handling. Like you can basically set a conditional breakpoint that will stop if there's an error or stop if there's a warning. Those are actually pretty handy. So we saw that MATLAB will terminate if there was an error like we saw when we put in the two different sized vectors. But if you can't quite figure out why things are the way they are, why they're not working, you can put in, you can click on the stop on errors, and that will then, when you run your function, if there's an error, it will be as if there was a breakpoint at that point. So it will terminate, it will suspend operation at that point and stop and give you control and give you insight into the workspace at that point. So then you can see why it's a problem. So I'm going to set a breakpoint right here at 5. And now I'm going to go run my function here. Let me go back over to here. And so I'm going to run just like I did before. Now remember, this created an error before, but we won't see the error right away because I've set a breakpoint prior to where this error will occur. So we run it and boom, it takes us back to the editor window and it shows us the green arrow pointing at where it has stopped. And so now, remember, this line has not run yet. This line has run. So I can come back over to the command line and look at my workspace, and I can see that I have X and Z were my two input variables. And then XX is the variable that was just created. And so that's created. And you can see the K, the keyboard cursor thing. And so now we can go over here and we can single step. So if I do a step, I now have run this line and nothing bad happened. I didn't get any errors or anything. I can come back over here and I can check. Now look, I have YY in my workspace. I can check the values if I want. I can check the sizes and so forth. Now I'm going to single step through. So this will be the next line that tries to run, and that will give me an error. So let me single step through that, and ding, I hear the ding. Notice that I don't have an error anymore. Why is that? That's because my function has now terminated. See, I'm out of my breakpoint. I'm out of debugging. So, hey, what happens if we go over here and redo this? I'm going to get rid of this breakpoint. I'm going to say the breakpoint is something here, but maybe I don't know where the error is going to be. Let me come up here to breakpoints and hit stop on error. So now you can see that's checked. So that means that's in effect. Now I'm going to come back over here and run my function. Same way as before. This will generate that error, but it will suspend operation when it hits the error. So ding, and look, I have no breakpoint set anywhere, but I've got a green arrow, and it's telling me it's sitting here. It has not actually run that line. So it tried to run it, realized there was an error, and then kind of backed up and said, I'm suspending right before that occurred. Now I can go in and see, well, what is X? And if I hover over this, it'll tell me X is 1 by 10, and it tells me what the values are. Z is 1 by 3. Oh, there's the error. Now I can quit debugging. I come up here, I quit debugging, and now maybe I need to fix this. So maybe I want this to be X transpose. So let's edit that. X transpose times Z. So now I'll have a column times a row. That will actually make X2 a 10 by 3 matrix, but that'll work just fine. So now let me run it. I have to save it. See the star there? It's telling me it isn't saved. So I have to save it. Now I come over here. Now I'm going to rerun it. I have no breakpoint set. I still do, though, have stop on errors, but there should be no errors this time. Should be. Hopefully I'm correct. Now I'm going to run it. No errors. And what does Y look like? Just as I expected, a 10 by 3 matrix. So this is showing you some of the rudiments of doing this, and using the step button, using the breakpoint, using the continue, using the stop if an error. There's a stop if warning. A warning doesn't actually terminate your program, but something is wrong. MATLAB is trying to tell you that something is wrong. So we'll stop there, and I'll see you in the next set of notes.